All right, we're going to look at graphs of motion in physics. We started our unit on motion, and part of that is to look at the graphs that represent that motion. This would be where math and physics come together. Besides equations and things, we're going to look at representing motion in picture form with graphs. And there's two basic ways to do that. We've got the graph with respect to time, where position, velocity, acceleration are on the y-axis, and it shows how the motion goes over time, or something called a ticker tape, which is basically a series of dots, and you kind of have to imagine that the dot happens at the same time, once every second, and it shows where that object would be if it was leaving a dot every second or so. And so what I'm going to ask you to do is to imagine something moving in a specific way. And so first we're going to talk about what the origin is, and that would be your starting point. And so you're either going to move towards a starting point or away from a starting point. And in this case, I'm going to start somewhere and move away from it at a constant speed. And this is what my graph would look like over time. It would be a nice straight line. Now, like we've talked about with these graphs that we create on the computer with our motion detectors, you can ignore the beginning and end of the graph and look at the good data in between. And so this shows how position changes with time. And you can see that with each second, the position changes the same amount. And so when we do our ticker tape diagram, it's going to be a series of dots that are evenly spaced. Now the other thing you can tell from a position time graph is how fast it's moving. And so if we take the slope of this graph, which would be position, the change in position divided by the time, you're going to end up with velocity. So I picked two spots on here. One of them is 1.8, 4, and then the other point was 0.8, 2, and found the slope using the change in y over change in x, and got it to be a ½ meter per second. This is a nice constant positive slope, straight line. You have a constant positive velocity of 0.5 meters per second. And if you look at the graph that just came up very, very carefully, while it does wiggle a little bit because of the resolution of the graph, it is slightly above zero and it is positive, so it's reasonable to think that we are at somewhere close to a ½ meter per second. Now the velocity time graph shows us how the velocity changes with time, and in this case it's pretty constant. And I know, like I said, it looks a little wiggly, but remember, it's real data, and I'll show you a good graph at the end of this little series. But if you look at this, it's pretty constant, and the acceleration of this would be the slope. So the slope is going to be 0 because it's a nice horizontal line. So the acceleration is 0. Constant speed, 0 acceleration. And so if you were going to draw these just to sketch them, the first one shows position time. This is an object moving at a constant speed away from the origin. You take the slope of that and you find that the velocity is a constant positive velocity. And then if you take the slope of the velocity time graph, since it's a horizontal line, there is 0 slope. So what you find is you have 0 acceleration. The slope of one gives you the other. So now we have another scenario where you're going to walk at a constant speed towards the origin. And so we end up with a negative slope, and just like before, slope gives you velocity, and so we have a negative velocity. It's a nice straight line, so it's a constant slope, so it's constant velocity. And then if you look at the velocity time graph that went along with this data, you'll notice that this time it's fairly constant and it's below 0, so it is negative and it is constant. So just to draw these up real quick for you, the position time graph shows a negative slope, a constant speed, and then if you take the slope of this, you end up with a negative constant velocity. Once again, nice horizontal line. If you take the slope of a nice horizontal line, you get 0, and so we have 0 acceleration. So now we're going to talk about things that are speeding up and slowing down. Sometimes we have to change our speeds. And so what that ends up looking like is a curve. And so what you can look at is with each second how the position changed. And you can see that between the 1 second and 2 seconds, the position moved about a meter. But between 2 seconds and 3 seconds, it went from 1 meter to 2 meters. So you're covering more distance in the same amount of time. And so our ticker tape diagram, the spaces between the dots is going to steadily increase. So when you're moving away from the origin while speeding up, if you look at the slope of the line, the slope is increasing. So it starts off pretty fast and then it gets steeper and steeper. If the slope is increasing, that means the velocity is increasing. And we can see that in the velocity time graph, where if you flatten that out with program that we were using, it would show a nice line, and you would end up with a constant positive slope, which would be a constant positive acceleration. And so if you look at these as a series of graphs, if the position time graph is curving up, which is showing you're moving away from the origin while speeding up, that means that the velocity is increasing because the slope of the line is increasing. So our velocity time graph shows an increasing velocity away from 0. And now when we do the slope of the velocity time graph, we're going to get a positive slope. It's constant, it'll be positive, and you'll have some sort of acceleration that's not 0. Now if we move away from the origin and slow down, it sort of flipped things around. Now we start off fast and get slow, so the slope starts off steep and decreases, so the velocity decreases. And you can see that in the ticker tape diagram where the dots gradually get closer and closer together with each second. And so back to the series of graphs, you have the position time graph with the velocity, with the slope decreasing. That shows that the velocity is decreasing with time. And so you get a negative slope of the velocity time graph that gives you negative acceleration. Since the velocity time graph is a nice straight line, acceleration is constant, but it is negative. So now let's move towards the origin and speed up. And so if you look at how the graph is lined up here, it shows that the spaces gradually get further and further apart. And so our ticker tape diagram shows the dots getting further and further apart because the object is changing position more and more with each second. So when we look at the graphs, the little series of graphs, it starts off, it is moving from some distance towards the origin. It starts off slow and gets fast. You can see that in the slope of the line increasing. And what that shows us is that the velocity is going to increase, but it's going to be a negative because of the way the slope is in the position time graph. Be careful with this one. A lot of folks will think that this is getting slower, but it's actually larger and larger negative numbers. And then you have the acceleration graph, which comes from the slope of the velocity time graph. It's a negative slope, it's constant, so it's a nice constant negative acceleration. So you had a series of graphs. Notice that they are related. So when you've got the one that's versus time, the slope of the position time graph gives the velocity of the object. The slope of the velocity time graph gives the acceleration of the object. Something to watch for is the position time graph really doesn't give you uphill and downhill. It just gives you a straight line distance. And a lot of folks will think, ooh, it's curved, so we must be going uphill. There's no up and down hill. It's moving away or it's moving towards. And on the ticker tape diagram, it's a different way to represent the motion of the object. And so if the dots are evenly spaced, it's a constant velocity. If the spaces increase, you've got increasing velocity or acceleration. And then spaces decrease, the decreasing velocity, which we also call acceleration because any change in velocity is acceleration. So good luck with the graphs. We will get lots of practice with these, and so it's just keep in mind this is really kind of cool. This is where math and physics starts to come together. Although you ever wondered what you were going to do with graphs? Well, here you go. So have a good evening. Bye-bye.